Welcome. Now doing 7.4. So your homework right now is 7.3. You need to do all 7.3 and 7.4. Sorry, I just had to double up. It is what it is, but I think you guys will be fine. I really do. I think you'll be okay with this. So here we go. 7.4 is the last set of notes for Unit 7. It's kind of nice. What are we going to be talking about? We're going to be graphing rational functions, slant asymptotes. It's a new word for you. Sketching the functions, asymptotes, and holes. You've already learned that, so some of it is going to be review. So let me move this out of the way. A slant, aka oblique asymptote. If the degree of the numerator is only one more than the degree of the denominator, it will create a slanted asymptote. If it is more than 1 degree, believe it or not, it will become whatever it reduces to because of limits and things. We are not going to go down any road that has bigger numerator degrees than denominators. We won't go. I will not ask you a question like that on anything, not even the supplement. So, but in case you're curious, because I know a lot of you are curious about things like that, we're only going to be referring to things that have 1 degree more. Feel free to play with your graphing calculators later, and you might be able to discover those things on your own. Right now it says, find the equation of a slant asymptote by using long division. The equation will be y equals the quotient without the remainder, everything but the remainder. So let's look at this. If I had x squared minus 9 divided by x plus 1, I say, what's the slant asymptote? You can use long division or because this denominator is a positive 1, you could actually even use synthetic substitution if you would like. So all I'm going to do now is I had to have a placeholder for the x row. 1, 0, negative 9. We could do the whole long division thing. Here's all the work. And I have x minus 1 times, and here's the remainder, negative 8. So here's the remainder. The equation of the slant asymptote would be y equals the quotient without the remainder. So it would be y equals x minus 1. And is there still a vertical asymptote at x equals negative 1? Yes, absolutely, because this factors the x plus 3x minus 3. It doesn't mean that anything would reduce, so there's no hole, and we just go from there. This is what the actual graph would look like if I were to plug it into a calculator or what have you. The vertical asymptote x equals negative 1. My slant asymptote is at y equals x minus 1. Dotted line. Here's negative 1, down 1, and then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on. Slant asymptote. Vertical asymptote. Well, how do you know where what goes? Like, how do I know that this is going to be on this side and this is going to be on this side? Well, there's ways to test for it. We call those two things test points. Test points. You can plug something in. As a matter of fact, if I were to go to the previous slide, I could plug in 0. See how 0 is right here? X is 0. Well, it's going to be down here. It's going to be a negative value. Let's see. When I plug in 0, 0 squared minus 9 over 0 plus 1. What is that going to be? Negative 9 divided by 1. Well, that's going to be negative 9. Guess where that point is? Down here. Negative 9. Bam. Make a point. If I know that this is the asymptote and this is the asymptote, I could basically have an idea that this has to approach infinity this way, and it has to go and get closer and closer to this line without ever crossing. So I could test a point and know exactly what the graph is going to be. And if this is on this side, I need to test the point on this side. I would plug in negative 2 to see if that would work. And see what that would be. Negative 2. It's probably going to be about negative 1. Let me see. Negative 2 squared is 4. Minus 9 is negative 5. Negative 5 over negative 1 is a positive 5. I think that is pretty close. So here's 1. You get the idea. So there we go. What you're going to have to be able to do is do everything I just showed you except without a calculator. It says graph without a calculator. Label all asymptotes, holes, x and y intercepts. Ooh, those are new. X and y intercepts are not new, but they're new because we didn't ask you for that last time. You were asked this time for full credit. Same thing goes on your quizzes and tests. Got to have all of those things for full credit. How do you find an intercept? X-intercepts? Where does it cross the x-axis? The y value is 0. If I want to know what the y-intercept is, it's where x equals 0. I'm going to let you guys try this, and you can take the next video when you're ready for the answers.